Hello, my name is Justin and welcome to my YouTube channel American Pie. Today we're going to complete Leetcode number 1390, Four Divisors. Given an integer array nums, return the sum of divisors of the integers in that array that have exactly four divisors. If there is no such integer in the array, return 0. So to start with, the first example is a list of integers 21, 4, 7. The output is 32. This is because 21 has four divisors, 1, 3, 7, and 21. 1 plus 3 plus 7 plus 21 equals 32, whereas 4 and 7 do not have four divisors. Example number 2, we have 21, comma 21. So 32 plus 32 is 64. Now, example number 3, nums of 1, 2, 3, 4, and 5. None of them have four divisors, so our return is 0. Seems pretty straightforward. Our constraints are that the numbers will be between 1 and 10 to the 4th. Okay, let's go ahead and get started. To start with, we're going to need a way to get all the divisors of a given number, and we need them to be non-duplicates. So we're probably going to need to use a set data structure to prevent duplicate divisors. For example, 6 times 6 is a valid divisor of 36, but we only want 1 6 in the list. So I'm going to use a hash set as our return value and create a helper function here called getDivisors. Next, we need to write an algorithm to determine all the divisors of a given number. Suppose we have a number like 36. We could just go from 1 to 36 and then check if each number we're iterating on is divisible. But if we do something like that, with our range being between 1 and 10 to the 4th, it's going to take a long time. So if we map out all the divisors of 36, we can actually see that every divisor is less than the square root of the number. So rather than looping from 1 to 36, all we really need to do is loop from I to the square root of n. But if we use the square root of n, it might not go in evenly when we try to do modulus operations. So rather than doing that, we're going to do the inverse, which is the square of I. Now in our for loop, we can go ahead and find the divisors. So if n modulus I equals 0, we know that I is divisible, so we can just add it to our set. But we can also derive what the additional divisor is. So if the formula is I times j equals n, we can derive j as j equals n divided by I. So we're going to add n divided by I to our hash set as well. Now finally, we only care actually about sets which have four divisors. So if we have 5 plus divisors, we should just break from this for loop and immediately return. We don't have to waste time computing. Now that we have the helper function done, we can move on to sum for divisors. So we're going to loop over the entire array of numbers, and we're just going to call our helper function to get the divisors of each number in the array. If the size is equal to 4, we're going to go ahead and add it to a sum, and all other numbers, well, they're not going to get added. So as you can see, the results are accepted. Now let's submit it. So as you can see, this beats 50% of submissions. It could probably be improved by doing this all in one function and not duplicating hash set in memory.